Here we're looking at the engine in the same orientation that it would be mounted to the motorcycle frame. I've already taken most parts apart. You can see I've taken the cover off of the engine. Here we have the carburetor. This is the cylinder. This is the crankshaft, the clutch, and on the inside, which I'm going to show you later, we have the transmission. I get started now with the carburetor. The carburetor is where the fuel and the air are mixed together to create a fuel-air mixture that feeds into the cylinder, which will then be combusted. This is where the air comes in, and next to it here we have where the fuel is connected. This goes directly to the fuel tank. Here we have an arm which is opened by the right side throttle, and when we open that arm, it opens up a valve on the inside of that carburetor, and doing so feeds more of that fuel air mixture into the cylinder, which is how we get the increase in revs. Next I'll show you. Here we have the cylinder. So I've removed the 4 screws that hold that cylinder down. I've also removed the piston, which is normally on the inside of this cylinder and connected to the crankshaft through this arm. First thing, I want to show you this hole. This is where the fuel air mixture from the carburetor goes in. It is controlled by a valve, and here we can see the top of that valve. That valve opens and closes through control of the sprocket. The sprocket basically is turned by a chain, which is connected to the crankshaft, and that is how we get an opening and closing of the 2 valves of the cylinder in the right time. The other valve is on the other side, as you can see here. This is where the exhaust from the cylinder comes out, and this is where we would have the muffler, which I've already removed. I edited this part of the video because I wanted to explain a little better what is actually happening during the combustion of the fuel. As you can see here in the middle, we have the spark plug. The spark plug is what creates a spark in the inside of the cylinder, and that causes the combustion of the fuel-air mixture. Now what a combustion is almost like a controlled explosion. So if you imagine this piston on the inside of the cylinder, towards the top here, above the piston is a compressed fuel-air mixture, and when the spark goes off, it causes that fuel-air mixture to combust and increase in volume, expand in volume. So that causes this piston to come down with a force. So this is where I would say the magic happens, meaning that the energy in the fuel is converted to a mechanical force. This downward movement becomes a rotation. As you can see here, this is where the piston would be attached, as such, and when the piston comes down with that force, it will rotate the crankshaft, and this rotation, because of the momentum, will continue, thereby pushing back up the piston. Now, the upward movement of the piston after the combustion is what pushes out the exhaust from the exhaust valve. Then we have another downward movement, which is when the fuel air mixture is sucked in from the carburetor side. And then we have another upward movement of the piston, which compresses that fuel air mixture, preparing it for the next combustion. And this is where the next spark is set off, and that of course again pushes down the piston and continues the rotation. And there are, as I am hinting, there are 4 different phases. There are 4 movements of this piston up and down, and those 4 movements are the 4 different phases of a combustion engine. And I recommend that you look it up to see what those are. Even the simplest animation will explain a lot to you. Yeah, and then I'd like to also quickly go to a view of the inside of the cylinder head, so that you can see the two valves and the tip of the spark plug. I want to use the sunlight to show you the inside of the cylinder. You should be able to recognize two circles, which are the valves, and the head or the tip of the spark plug. What we can see on this side, this is the arm that is connected to the crankshaft. You might be able to see there are some counterweights inside this system, and that is also how we have the momentum to continue the rotation as the engine goes through all the phases, the 4 phases of the combustion cycle. Inside here is where we have a sprocket. The sprocket has a chain around it that I've removed. That chain goes all the way up through to the cylinder itself and controls the opening and closing of the valves through that sprocket here at the top, which I mentioned before. If we look at this from the bottom, you'll see again the space designated for that cylinder. And here on the other side is where we have the 2 coils. You can see the crankshaft is still rotating between those 2 coils. This is these are magnets. Those magnets, I'll show you from the other side. Those magnets sit on top of, they sit around the 2 coils, as you may have already studied. Magnets rotating around electrical coils will generate a current inside those coils. So what we have here is a production of electricity. That is the electricity that charges our engine. That is also the electricity that generates the spark in the spark plug. So it's really through the crankshaft that we have here that we get a coordinated opening and closing of the valves in the cylinder head, and is also how we get the coordinated spark on the spark plug. So if you're wondering how is it that the motor knows to open and close any of the valves, how is it that it knows when to set off the spark plug, it doesn't. It's the crankshaft that does it for us. And before I continue, I wanted to show what a spark plug looks like. These threaded ends are what thread into the head of the cylinder, and it is in that tiny gap here where we have the spark that sets off the combustion. As you can imagine, the reason why cylinders are typically rigged like this, have these ridges, is to disperse the heat that is generated inside from the combustion of that fuel. Okay, I've reattached the magnet. Underneath here are the electrical coils, and with the magnets on top that rotate with the crankshaft, that is how we generate the electricity. And you'll notice that now when I simulate the piston movement, it's not going so smoothly anymore, and that's because I'm fighting against the attraction of the magnet. But this is how it would go. What's going on with the piston inside the cylinder? And as I mentioned to you before, that there is a sprocket on this crankshaft which controls the opening and closing of the valves on the top of the cylinder. This is that sprocket. This in the front here is the ignition. When we press the ignition on the motorcycle, we're sending a current from the battery to this electrical motor. That's basically what it is, and that generates a rotation here, and by way of the chain, that rotation starts to rotate that crankshaft manually. Now the movement of the crankshaft is linked to the movement of the piston, is also linked to the opening and closing of the valves, and the generation of the spark at the spark plug, everything that the engine does naturally when it is running on its own. And thereby, by having it go through the motions, once the motor starts to harness the energy of the fuel into a mechanical force, it then continues to run on its own. That's basically how we get an electrical ignition to start our engine. So I've shown you now the carburetor, the cylinder, and the crankshaft. Next thing I'm going to show you is the clutch and the transmission. Just a quick video of the clutch before I take it apart. So the clutch, in effect, it engages and disengages the rotation of the crankshaft to the rotation of the sprocket. Okay, and this is happening by what we have here, an outside and inside part of the clutch. Okay, here if I take the first clutch plate apart, you can see that we have teeth on the outside of this clutch plate. So this is linked to the outside of the clutch, and in between these clutch plates we have these rings which have teeth on the inside, meaning that they are linked to the inside part of the clutch. So this is what we have. The crankshaft through these sprockets turns the outside part of the clutch. So the outside part of the clutch is what is linked to the movement of the piston, and the inside of the clutch is what is linked to the sprocket through the transmission. And here is where the two of them become synchronized, is that when we let go of the clutch, we are allowing these plates to rub on each other and eventually, through friction, to turn at the same speed. Now I'd like to demonstrate to you what this looks like in action. As you can see here, we have the inside part of the clutch rotating while the outside part of the clutch is still. If I remove this one, you can even see the plate that corresponds to the inside part of the clutch rotating while the outside is staying in place. And if I let go of this sprocket, which is linked to the crankshaft, if I let go of it, especially if I do it slowly, then you see after a while they have to become synchronized through friction between these plates. Now if I go back to holding the sprocket that is linked to the crankshaft, you can see I'm able to turn the inside part of the clutch, and if you could see on the other side, you would see that the sprocket that would be linked to the rear tire is turning. Alright, let me quickly take the camera off to show you that. So again, I'm turning the inside part of the clutch while the outside part stays in place, and we have the sprocket turning. And if I let go of the outside part of the clutch and the two rotate together, then we have not only the sprocket rotating but also the crankcase. Now I'm going to demonstrate to you what it would look like if we were pulling on the clutch lever on the left side of the handlebar. This is where the cable to that clutch lever is attached to normally, and when I pull on it, excuse me, you can see the clutch cover separates. Let me zoom in so you can get a better look of that. Even though it's a very small noticeable difference, as you can see here, I'm pulling on it and now I let go. Pulling on it, let go. So the clutch cover moves away pushing up against the clutch springs, thereby reducing the friction between the clutch plates. Let me demonstrate this. Pulling, let go. Pulling, let go. Pulling, let go. That's it. Okay. If you can visually see, the rod that the end of our clutch cable is attached to, it touches on the other end of this shaft. And on the other end of that shaft is where we have, or inside of the shaft, sorry, is where we have this rod with this ball at the end. So by pulling on the clutch lever, what we're doing is we're moving this out because of the shape that's at the bottom of this piece that I just showed you. And by pushing it out, what we're in effect doing is pushing out this clutch cover. This clutch cover sits inside of that shaft, and so when we pull the clutch lever, pushing this rod out towards us, what it does is it pushes away the clutch cover, and that is how we get the reduction in friction between the clutch plates, because this clutch cover, it's mounted onto the clutch with these clutch springs, and those clutch springs are what increase the friction between the plates. So by pushing the clutch cover out, we are allowing more space between the clutch plates, and that reduces the amount of friction. So that is how we are able to control the engagement and disengagement of the clutch. I removed the clutch. Now I want to explain to you this piece here. This piece is connected to the lever on the left side of the motor that we use to shift up and down in gears. As you can see, when I move that lever up and down, it's also moving this piece here. It comes back to this position because of a spring that's sitting behind it, and it has these teeth that connect to this device back here. And if I can get at it, this device has an arm that I've pulled down here now for you to see, and this arm this arm moves back and forth depending on whether we're shifting up or down to rotate the circular piece behind it. And that circular piece is going to be very important to explain to you how the sprockets shift in the transmission when we shift in gears. So just to demonstrate an example, I'm going to shift up right now. Let me shift down instead. Okay, so that's a downshift. Let me do that again so you can see closely. And if I shift up, it looks like this. Let me do it again. Okay. Now I'm going to take this whole thing apart, and you're going to see how the sprockets move when we shift in gears. These are the two parts of the motorcycle engine. On this side we have the crankshaft, and here's the counterweight. I'm going to put this one away. And here on the other side is the transmission. I'm going to demonstrate to you what this looks like when we shift through the gears, and then I'll come back to explain to you how this is happening. We're going to shift down from 5th gear to 1st gear. Now again, with my left hand, I am producing the same rotation that we would have if we had the piston moving up and down. So right now it's 5th gear, we're in neutral. This is 4th gear, neutral. 3rd gear, neutral. 2nd gear, neutral, and 1st gear. Okay. If I give you another camera angle, 5th gear, neutral. 4th gear, neutral. 3rd gear, neutral. 2nd gear, neutral. 1st gear. Now I'm going to show you those tracks that I mentioned. Okay, so this is a good angle. can see here, we have 3 tracks. The 2 outer tracks correspond to the position of these 2 arms, and the inner track corresponds to the position of the arm on this side. As you can see, depending on whether or not that track moves to the left or right, it will also shift that arm in that direction. The rotation of this device is controlled by the lever on the left side of the engine that we use to shift up or down. The way in which the system avoids stopping the rotation in between gears and making sure that it actually shifts completely from the position that corresponds to one gear to the position that corresponds to the next gear is controlled on the other side. As you can see here, this round object is the other side of that rotating system with the tracks for the arms. And if you can see, it has a sort of star shape around it. This arm here, with that circle attached to it, pushes against this device, specifically on the surface of that star, and by doing so it makes sure that when this object rotates, it will not come to a stop in between gear positions, meaning that the low points on the surface of the star are the positions that correspond to specific gears. The gear that it's in right now is actually at the peak between 2 low points on that star, on the surface of that star, and that specifically is the neutral position between first and second gear. I'd like to demonstrate to you how this actually works. It's a little bit difficult, so if you'll bear with me. Now we are in first gear, neutral, second gear, third gear, fourth gear, and finally fifth gear. One last thing on this side that is worth mentioning is these 2 sprockets down here. It's pretty rare to see a plastic sprocket, but when you do, you should know that this is part of the oil pump system, and it works to circulate the oil that we have inside the engine to make sure that all the parts that need to be lubricated are indeed lubricated. I finished showing you the inside of a motorcycle engine, something that some people never get to see in their entire lifetime. Now, with that knowledge, I hope that you can start to apply things that you know about a motorcycle's performance and try to understand how it works from the level of the engine that we went through. For example, how the performance of an engine changes if it has a single cylinder versus 2 or 4 cylinders. The other thing that I also encourage you to do is to think about, for example, what other ways there might be to transfer the energy from the fuel to mechanical force. This engine that I showed you, it's running on a carburetor, which perhaps might be the only change in the past 40 years of motorcycle history. And nowadays there are a lot of motorcycles that run on fuel injection. However, the combustion part of the engine is still exactly the same, and it's not a very efficient way of converting that energy. Therefore, I ask you, can you think of any other ways that we might be able to convert the fuel to mechanical force? Anyway, there's a lot of bright minds out there. I'm sure some of us will come up with some great ideas. Anyway, thank you for watching.